5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Hey space friends, we're back with a new episode. 2 words, space robotics. Gitai, founded in Japan and now headquartered in the US, wants to significantly bring down the cost of labor in space. In orbit, on space stations, on the moon, even on Mars, with its robotic technology. My guest is Gitai's founder and CEO, Sho Nakanose, and he'll tell us all about it. Enjoy. My name is Raphael Rodkin, and I'm an investor and advisor to space companies. Just as a reminder, this podcast is for informational purposes only, and nothing should be taken as investment advice. This podcast is sponsored by Nano Avionics, a satellite manufacturer and mission integrator. Their technologies enable many space companies worldwide to offer services that improve life right here on Earth, such as providing global connectivity, conducting Earth observation, or contributing to scientific discoveries. Check them out, and also check out my episode with their CEO and co-founder. Sadly, I am not a rocket scientist, but I'm an alumnus of the International Space University. ISU offers a number of educational programs about space worldwide. Check them out at isunet.edu.
And just some final things before we start the episode about ourselves. If you enjoy the podcast, please leave us a 5-star rating on your favorite podcast platforms such as Apple or Spotify. If you want us help expand our work, you can do so and support us at www.patreon.com/Space Business Podcast, and we'll also put that link in the episode notes. And lastly, you can follow us on Twitter at podcast_space.
Hey space enthusiasts, welcome back to the first episode of 2024, after our 2024 preview episode. That is, if you haven't listened yet, you should listen to it. It gives you the preview of all of the exciting things which we think will happen in the space sector this year. But now, with any further ado, my first guest for 2024 is Sho Nakanose. He's the founder and CEO of Gitai from Japan. Welcome, Sho.
Thank you for having me.
Yeah, it's a great pleasure. We're looking really forward to hearing about Gitai. Could you start off, as always, and do you mind giving us sort of the short summary, the elevator pitch, if you will, of Gitai, please?
Sure. Hello, everyone. I'm Sho from Gitai. And Gitai is a space robotic startup that provides safe and affordable means of labor in space. So we've been developing space robots, mainly 2 space robots. One is robotic satellite equipped with robotic arm, capable of conducting rendezvous, docking, and maintenance, inspection, and life extension operation for the target satellite. And the other is a lunar robotic rover equipped with robotic arm, capable of moving around on the moon and conduct various operations such as maintenance, inspection, repairing, excavation or mining, and even construction of solar panels or communication antennas on the moon. So we are not just a robotic supplier, but a labor provisioning servicer on our hourly charges using our robotics technologies. So that is our vision, and minimizing costs in real time dramatically, enhancing the performance rapidly, and minimizing the cost of working in space by 100 times. That is our vision, and that is who we are.
Thank you. And of course, Japan has a very long-standing and proud tradition of robotics. But in your case, how did you decide to start Gitai, and how did you decide there should be a space robotics-focused company?
Yeah, I think this is a very unique story because I don't have any robotics nor space background originally. And so I established the company 7 years ago. But before that, I had worked for IBM Japan as an IT consultant, but it was a really boring job for me, unfortunately. So I decided to leave the company, and I established my first company in India to develop web applications and smartphone applications. And after 2.5 years, I sold my company and business to a big organization. And using that money, I have started to develop prototype of Sci Fi-like robot, which was our very first prototype of Gitai robot before the establishment of the company. And it was just my individual project originally, since I have loved science fiction since I was a child. So using that money, I've been developing my own personal project, like sci-fi-like robot. So yeah, as an individual project, and but I was really into that project. So I have decided to establish my second company as a startup, and that was Gitai. And I have conducted like a lot of interviews and researches to potential markets, such as not only space industry, but also disaster rescue and remote medicals. But I saw a significant growth potential in the space market because humanity has been expanding horizontally. But now is the time for us to expand vertically. And thanks to the SpaceX, the biggest bottleneck in the space industry have been changing from transportation cost to operational cost. So I've decided while SpaceX is reducing the cost of transportation to space by 100 times, we at Gitai are taking on the challenge of reducing labor cost in space by 100 times using our robotics technology. So yeah, that's why I established our company.
And when was that?
It was 7 years ago.
7 years ago. So of course, this is roughly also when I got started more seriously in space. And I remember this was a time when, so today, obviously space is a lot in the news and people talk a lot about it. And there's millions of people watch like, Starship test flights and so forth. But 7 years ago, this was very different, right?
Yes,
and so
yes.
How was it for you at the beginning? Like you were pitching a space robotics company, and then I think even the experts, they said, okay, space robotics, there is the, I guess the Canadarm on the International Space Station, but the use cases were not so clear yet, probably to most people.
Yes.
How was it to start out and try to pitch and try to convince people that this was worthwhile?
Yeah, it was just passion, so I believe. And but as you said, like when I established the company, 7 years ago, bringing just my tiny prototype and without any co-founders, like people said, establishing the space robotics company was the most stupid idea I've ever heard. And no markets and no concrete use case, and there's only International Space Station in space with the kind of operation and no human being on the moon and Mars. But so I've met like a lot of venture capitals, but they said like there was no market and no use case. So don't establish such a company. But I strongly believe it's a time for us to expand vertically and like not only just like Roman like going back to the moon or something, but also the confliction between the US and China was escalating more and more. So like I believe not only just like science mission, but also like space mining and defense purposes. That kind of like strong motivation would lead the expansion of the space market, and the biggest bottleneck in the space industry would be changing from transportation cost to operational cost thanks to the SpaceX challenges. So yeah, that's why I just believed, and probably like because of my strong passion, some like investors believed my passion and past track record as my previous company. And then I got $1.5 million US seed round funding, and I could start hire talented engineers. And then the market timing was like coming to the we could gradually generate sales figures and track record and showed the successful space demonstration in 2021. So yeah, that is our first step. It was very hard, but it turns out very right timing.
Okay, so you got the $1.5 million venture funding. You said you hired technical people, and I guess you probably built something like a prototype. You said there was an in-space demonstration. When did you feel that sort of this skepticism that people may have had, both investors and customers? When did you feel it may have started to shift? And what do you think may have been the main reason it started shifting?
I would say that was like defense. Purposes, the like confliction between the US and China and Russia. So that may escalate the expansion of the budget to especially on-orbit servicing business domain, and starting from 2 or 3 years ago, and also like some investment from government and commercial space companies such as Blue Origin and to the lunar surface to build a like kind of a gas station for rocket and like ISRU plants, and that kind of motivation from specific commercial space companies would lead the like expansion of the lunar market. And I believe like SpaceX will lead the expansion of the market to Martian surface. But it will take more time. But based on that, specific organization or commercial space companies nowadays lead the expansion of the market, and also like DoD defense purposes. DoD leads that specific market, especially on satellite servicing market.
Okay, and so let's talk a little bit about let's talk a little bit about the use cases. But actually, let me take one step back before that and sort of try to understand your product. And you already described there's actually two products, right? Because you also have the rover. But just to try to understand them, maybe starting with the robotic arm in orbit a little bit in more detail. Like, for example, is it? Can you describe it a little bit? What it looks like, what its size is, what its functionalities are, and also I was curious whether you were just doing the hardware, or whether I assume you're also doing like the control software for the hardware.
Okay, yeah. Actually, we've been developing like space robots in the Agile development method based on the in-house production. So first of all, we develop everything in-house, including the hardware, software, and all of the avionics by ourselves. And as for the we have two products, and one is robotic satellite equipped with 2-meter sized dual robotic arms with like 500 kilogram class satellite, and capable of conducting rendezvous, proximity, and docking, and also conduct various operations such as maintenance, inspection, and life extension operations, and in-space assembly operation for the target satellite. So that is one product of ours. And the other is a lunar robotic rover, 2-meter sized lunar robotic rover equipped with 2-meter sized lunar robotic arms, and capable of conducting maintenance, inspection, and repairing, excavation or mining, and even assembling solar panels from smaller separate parts autonomously. And also that lunar robotic rover has and robotic arm has a tool changer functions, so that end effector is interchangeable. And also that our robotic arm is not fixed robotic arm. Through the dedicated interfaces, our robotic arm can walk around like horizontally and vertically through our dedicated interfaces. So we called it inch-arm types robotic arm. With moving function. So that is our main capability for on-orbit satellite servicing and lunar surface, lunar infrastructure construction business domain. And with our vertical integration. So we've been developing everything in-house.
And so when you first started and you said, okay, you want to build space robotics, and again, Japan has a very proud tradition. Japan and some other countries, very proud tradition of it's called terrestrial robotics, right, for various industrial purposes. How did you and your engineers go about it? Like, for example, did you go and analyze, okay, everything that's available on Earth, and then you try to see, okay, what do we have to adapt for a space environment? Or did you maybe start more from a approach from scratch, kind of ignoring what's on Earth? Or did you look at the historical precedents of the little space robotics we had, like on, Space Shuttle and International Space Station? Or what was the approach there?
I think that is one of our biggest feature. So actually, most of us are not space guy originally. So only a few of us are from space industry, but a majority of us are from terrestrial industries, and mainly robotics researchers on the terrestrial market. So now we are bringing the advanced robotics technology, especially autonomous robotics technology, from terrestrial industry to the space industry. I think that is one of the biggest feature and our challenges to enter the space market. So we have our advanced general purpose autonomous robotics technology originally, but and we hired that kind of engineers mainly in Japan, in Tokyo, and who has specialty in their autonomous general purpose robots such as disaster rescue, remote medicals, humanoid, autonomous robotics. So we have originally we have a strong confidence to realize the most advanced general purpose robot which capable of conducting various operations autonomously. But we had to realize and conduct countermeasures to withstand the harsh space environment. So we have we have conducted that necessary environmental testing by ourselves, such as thermal vacuum chamber, thermostatic chamber, and vibration, radiation, and even rigorous chamber testing by ourselves. So that is totally in-house production and manufacturing. So originally we have hired great engineers who has advanced robotics technology, and then we have conducted countermeasures by ourselves.
And speaking of the countermeasures, so of course you mentioned the two products you have, like the servicing, or I guess more for use in orbit, but then the lunar rover, and on the moon the environment is even much harsher. So I guess then you have to take additional countermeasures for the radiation probably, and maybe even like the regolith and so forth.
Yeah, true. And we already have completed our environmental testing for our space robots in low Earth orbit and GEO, but now we are conducting lunar countermeasures such as rigorous chamber testing and cryogenetic testing, coating with glass for cameras to prevent lunar regolith from inserting our motor module unit. But we already have completed our first technical demonstration inside the International Space Station in 2021, and we have succeeded in assembling solar panels from smaller separate parts autonomously. And now we are challenging to conduct external demonstration, so outside the space station. We have just launched our 1.5 meter sized dual robotic arms to the outside of the International Space Station just 2 weeks ago. And we are now conducting our external demonstration at the harsh space environment outside of the space station. So it's gonna be our first demonstration will be conducted outside of the space station, so harsh space environment.
So this is happening right now. This will happen in the next few weeks, you said?
Oh yes. Now NASA is installing our robot outside of the Bishop Airlock, mounted on the International Space Station, and we are going to start our external demonstration in 2 weeks.
And what will this demonstration involve? Will you again be assembling some structure, or what precisely will you do?
Mainly various types of operations required for on-orbit satellite servicing, such as maintenance, inspection, and some kind of a life extension operation. So attach the hardware on the task board, kind of like mock-up of the customer satellite, using the tool changer functions. And that is one of the technical demonstration to conduct actual operation required for on-orbit satellite servicing. And also it's going to be a proof of our countermeasures capability to withstand the harsh space environment.
Yeah. I mean, speaking of the International Space Station, I mean, as many of us space fans know, regularly astronauts on the International Space Station go out on what we call the extravehicular activity, right? Or colloquially called the spacewalks. And they do that because they have to repair something, basically. But it's of course it's dangerous. It's very expensive. So do you also see the possibility in the future that maybe some of your robots could help to service the International Space Station?
Yeah, I hope so. But we aim to provide our robotic workforce to lunar surface and Martian surface more. As a main labor in space, and minimizing the cost of working in space by 100 times. So I think we should divide each roles. So human astronauts has their own roles, but they don't need to operate dangerous operations in space or daily chores. So actually a lot of human astronauts have visited to our office, like Japanese office and US office. But they sometimes complained how boring operations they have to conduct in the International Space Station. And we could replace such a boring daily chores, cleaning and maintenance, or dangerous operations with our robotics capabilities.
Yeah, but now we're crossing over now into basically the use cases that I want to talk about. So both for your servicing robot and platform, as well as for the lunar, where do you see the main use cases? Like what will these machines do, and then also which ones are you maybe most excited about for the near term?
Yeah, our long-term goal is to provide robotic workforce to build infrastructures on the moon and Mars, such as thousands of solar panels, communication antennas, habitation modules, and even ISRU plants, and on the moon and Mars. So that is our main goals, and it's gonna be our biggest contribution to humanity. But of course, we need to generate sales figures step by step. So we are targeting for not only lunar and Martian surface, but also on-orbit satellite servicing. But our major capability is to assemble solar panels and communication antennas using our autonomous lunar robotic rover and lunar robotic arms. So actually, we have succeeded in demonstrating that construction of solar panels and communication antennas, building a tall tower using our autonomous robotics capacity. So that is our most exciting mission. And actually, we've been awarded a contract from DARPA recently, which is called Lunar 10 contract, and which is a lunar infrastructure construction mission. And we've been selected one of the 14 US companies from DARPA, and we will be in charge of providing robotic workforce to build infrastructures such as solar panels, communication antennas on the moon. So that is exactly what we want to do on the moon in the near future.
And so for the, you said the in-space assembly, we'll come to the moon in a second, but the in-space assembly, would that also then involve, I guess, the potential construction of very large structures? So of course, some people are now working again, for example, on ideas of space-based solar power, where we need very, very large arrays and even larger than what you could fit in a Starship that you need to assemble. I guess this is something where your robotics could also help assemble these structures.
Yeah, we'd love to provide our robotic workforce to that huge mission. And but I also believe what was the biggest bottleneck and problem in this space industry would be everyone just talking about that concept and bringing just PowerPoint presentation or computer graphics. Yeah. It looks very good, very, very beautiful, but no one can realize that actual capability. No one cannot realize the actual hardware and avionics and software. That's the most important part. And of course, making a good business would be next step and next important things. But originally, we should develop that actual products instead of just creating presentation PowerPoint or computer graphics. So that is our strong culture. We always develop actual hardware and software and to show actual capacity. And so we have succeeded in assembling that actual solar panels and communication antennas using our robotics capacity. And even it's just ground demonstration and in the Mojave Desert. But we can show that actual capacity and demonstration and to you and to our potential customers and investors. That is our strong culture, and we hope to contribute that actual in-space assembly mission.
Yeah. And so on the way to like, the ultimate vision of a workforce, a robotic workforce on the moon and maybe even Mars. So for the near term, like what does that mean in terms of like the types of customers you approach? Like who is your product useful for right now?
Yes. So most of our existing customers, we cannot disclose, but we already
The types,
have
the
been.
types of companies. Yeah.
Yep.
Like not
And
without giving any names.
I think like three types of categories will lead that in space assembly or that market. And one is of course like NASA, and NASA actually is creating that concrete mission called Lift One, and will be disclosed this year. And also DoD related organizations and will lead that market. And since we already have been awarded a contract from DARPA, and lastly, specific commercial companies such as Blue Origin and SpaceX will lead that market. So initially, that three limited potential customers will lead the market, we believe.
And I guess when you mentioned Blue Origin, also there is, and we talked about the ISS, but I guess there's also like all of these potential future space station projects, right? Many of which want to, for example, do things like in-space manufacturing. So I envision there's also a upcoming need for robotics in these new space stations.
Yes, we cannot disclose it yet, but yeah, we already have collaborated with that.
Okay, and so for the moon, you mentioned some examples already, like the ISRU, the habitation, and so forth. If you had to take a guess, what will be the first like big scale use case of robotics on the moon? What would be your guess?
So these are like based on the concrete demand from like specific commercial space companies in the US and also DoD and NASA. But now they are trying to build a kind of a gas station on the moon. So yeah, based on the using that, how to say, lunar sand called Legolis, they are going to produce liquid oxygen, and if we get like ice grains, like water on the moon, we also can produce both liquid oxygen and liquid hydrogen. It can be used as a fuel for liquid fuel rocket, such as Starship. And so yeah, they are going to build a kind of a gas station on the moon to go to Mars and furthermore. So I think the meaning of the like ISRU at the lunar surface would be like producing the kind of a fuel on site for liquid fuel rocket.
Okay. And when do you envision to have your first lunar demonstration, and what may it look like?
Yeah, actually, we already have our like concrete plan to conduct our lunar technical demonstration by ourselves, targeting for the late 2020s. And we are going to conduct two major operations. One is excavation or mining operations, like to collect lunar sand. And the other is a in-space assembly operation. So our lunar robotic rover and lunar robotic arm is going to assemble solar panels to the lunar surface from smaller separate parts autonomously. And then we can get electricity through that assembled solar panels. That is our, that operations are going to be our first technical demonstrations at the lunar surface.
And do you envision, you said it's already a plan, so are you already booked on maybe a specific mission, maybe one of the Artemis missions? And then would you be doing this for a customer or under a government contract, if you can disclose these things?
We cannot disclose that yet, but our first demonstration will be like our own lunar demonstration. So not as a customer mission, but yeah, our own technical demonstration to take a risk more.
Okay, understood. And is it a specific mission you have booked already, or are you still evaluating which mission it might be?
Sorry, we cannot disclose it, but yeah, we are going to disclose as a press release about that.
Okay, understood. So maybe talking a little bit about your vision and timeline in general. So as you mentioned a few times right now, you had your first ISS demonstration in 2021. I guess you had some demonstration in Mojave Desert as well, as you mentioned. You're now currently conducting the demonstration outside the ISS, which of course is very important to evaluate how it behaves in the actual space environment. What are the next major milestones for Gitai along the years?
Actually, how to say, in addition to the future lunar demonstrations, we have our 2 additional demonstrations in the very near future. So that would be our upcoming major challenges. In addition to future lunar demonstration and customer missions. So we are going to launch our spacecraft, Gitai's spacecraft, to low Earth orbit the end of this year. And also we are going to launch much bigger Gitai's spacecraft to also low Earth orbit next year. So that 2 additional demonstrations will be really, really difficult challenges, but are also very great challenges for us to enter the on-orbit satellite servicing market.
And so what will these missions entail? Like, what will these spacecraft do? Like, for example, will they try to do some sort of rendezvous operation or some other manipulation?
Yeah, both 2 demonstrations in a row. We are going to make sure our satellite function. First demonstration is to launch Gitai's in-house satellite to low Earth orbit and to see if our satellite function correctly. And the second demonstration next year, we are going to launch much bigger robotic satellite, Gitai's in-house bigger satellite equipped with 2 robotic arms and capable of conducting rendezvous, docking, maintenance, inspection, and kind of a life extension operation for the target smaller mock-up of the target satellite alongside with bigger robotic Gitai satellite as a servicer. So that is our first technical demonstrations in low Earth orbit as our on-orbit satellite servicing. So not only just friendly docking, but also conduct various operations for the target satellite. So that is a real technical demonstrations targeting for on-orbit satellite servicing.
And then would the business model be that Gitai itself provides these on-orbit services, or would you sell your technology to other companies who want to provide these on-orbit services?
Yes, we don't want to be just a robotic supplier, but a labor provisioning servicer to as a prime contractor to DoD related organizations and commercial space companies. So now we've been developing not only robotic arms, but also satellite in-house. To be able to provide on-orbit satellite services as a prime contractor to DoD related organizations such as Space Force.
Okay, understood. And so then you would end up also competing with some other companies who also want to do, I guess, similar things.
Yes.
And we don't have to mention them, but I think people know the types of companies they are. Okay,
Yes.
good. And then so if you take a little bit of a longer term view, right? And I guess we've already talked about the moon. It already is somewhat longer term, but maybe even further out, sort of like your ultimate vision. And you already talked about it a little bit, but maybe 10, 20 years in the future, if all goes well with Gitai, what would you like to see?
So thousands of our Gitai's space robots on site, and build infrastructures such as thousands of solar panels, communication antennas, habitation modules, and ISR plants on the moon and Mars. That is our future vision, and minimizing the cost of working in space by 100 times. So that is our only metrics, Gitai's contribution to humanity. That is our future vision, and so at that time, like we are not robotics company, but a construction company with Gitai's robots.
Mm-hmm. And so let me pick up, because you mentioned this a few times now. This, of course, is very important. This reducing the cost of labor by 100 times. What is so? I know this may be a difficult question, but I try to like get to sort of a more specific number. So, for example, I know that right now, if you're inside the International Space Station and you have the astronauts, I think like NASA has a rate card, right? How much it costs if you commercially want to use astronaut time. And I think last time I checked, it was something like $130,000. It was very, 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 very expensive, like even more expensive than like lawyers per hour. And so is this like the sort of right starting point? If I take $130,000, I divide it by 100, this is kind of the cost you're targeting, or where do you think we get to in terms of operational cost?
Yes, that is exactly what we aim to reduce the cost. And so there are only two ways to conduct operations now. And one is human astronaut. And as you said, it costs $130,000 per hour, and with safety issues. And also there is of course existing robotic arms such as Canadian arm, but it also costs $1.2 billion per unit with long lead time. Not company variation, but just single robotic arm costs $1.2 billion. It's incredibly expensive. So we aim to reduce the first of all, we aim to reduce the cost of human astronauts. Astronauts cost to 100 times. So using our space robotics technologies developed in-house. So that is our major challenges.
Mm-hmm. And so coming back to the products, right? So again, we have now your spacecraft with the 2-meter arms, a lunar rover with 2-meter arms, if I remember correctly. And if you look further out, again, so for 10, 20 years, what else do you maybe see what type of machines do you see on the product roadmap in the future?
Yes. Maybe we have our two products. One is robotic satellite, and the other is a lunar robotic rover equipped with robotic arms. And that lunar robotic rover and lunar robotic arm will be our major products, and going to mass production in the in 10 years, 20 years. So to build infrastructures like solar panels, communication antennas, habitation modules, and ISR plants. I think if we really want to build infrastructures on the moon and Mars, we need to design the space robots not as just one-off items, but are future mass-produced products. So we need to minimize the number of products as much as possible to produce as a mass production model. So, and then we already have designed two combination. So inch one types robotic arm with tool changer functions and inch one working function. And that is one major capability for lunar and Martian surface. And also as a moving function, we have lunar robotic rover to bring the module for infrastructure construction to necessary location. So we separate operational robot and moving robot, and that is inch one type robotic arms and lunar robotic rover. So that's two combination of space robots are going to be our major products in the very near future.
Mm-hmm, mm-hmm. And when you say mass produce, and of course we all hope this will happen, because that would mean there's a lot of activity on the moon. But what do you envision? Is this going to be sort of like dozens or hundreds of units or even thousands of units? And then the next question would be sort of the supply chain you need and the various parts you may need, whether this is actuators or sensors. Is this supply chain in place, or do you have any worries that there may be a bottlenecks somewhere?
Yeah, we hope to produce as much as possible, not just 100 units, but a few dozen, thousand units. That is our mass production, we believe. So if it's just 100 robots, we can produce as a extension of one items manufacturing. So we don't need to build a like mass-produced factory or something. But if it's more than 10,000 units, we need to build a mass production model and with mass-produced factory. So yeah, we hope to produce that number of like more than 10,000 units like of Gitai robots to like lunar surface and Martian surface. But in order to realize that, and also in order to reduce the cost and lead time dramatically, we've been developing our robots in-house. So including all of the necessary components like mechanical engineering, motor module unit, and even motor driver itself, and all of the necessary avionics, electrical circuit, and even software development, including autonomous software development in-house. So that is our one of the biggest feature, and minimizing costs and lead time dramatically, enhancing the performance rapidly. So that is a vertical integration alongside with like SpaceX manufacturing. So we are going to expand our vertical integration more and more if we produce the plenty number of our space robots.
Mm-hmm. Because part of the reason I was asking about supply chain, because I guess on the similar time frame that you will be doing this, right now on Earth, there is, I guess, a drive to develop more robotics and also like new type of robotics with the humanoid robots, right? So you have, of course, Optimus at Tesla, and then there is probably at least a couple of companies, some with extremely significant financing and stealth mode for humanoid robotics. But actually, that's an interesting question as well. So do you see, I'm sure you're following all of this, the Optimus and the other humanoid robotics. Do you see do you see this may also be something that we will ultimately have in places like the moon, like the type of humanoid robot to help us?
Actually, like the majority of our core engineers and researchers are former humanoid robotics researchers, and especially our chief robotics officer, Dr. Yuto, was a former assistant professor at the University of Tokyo, and at a humanoid robotics group, and he led the humanoid robotics development and researches at the University of Tokyo, and he was a former founder and CEO of Shaft, which won first prize at the qualifying round of DARPA Robotics Challenge in 2013, and acquired by Google. So we and actually the first prototype I developed personally 7 years ago was humanoid robots. So we love to like develop humanoid robots, but also we saw some insight both technically and from the business point of view. So we don't need to design humanoid types robot if we provide robotic workforce to conduct various operations to the like lunar surface, Martian surface, and even terrestrial market. If it's a like teleoperation, humanoid types robot is very has a great advantages for human operators to control. But if it's an autonomous control, we believe we don't need to design like humanoid types robot. And technically, like for example, 5-finger hand is very, very difficult. And if we try to develop that robot as a product, like for human customer missions, and with reliability as a product, it's very fragile. And so like tool changer functions, so like robotic hand and backhoe and like electrical drill, that kind of a tool changer function is more reliable and realistic way to conduct various operations technically, we believe. And also from a business point of view, if we look at like terrestrial market, we needed to overcome the strong competitor called human labor. And the performance of human labor is much higher than current general purpose robotics technology, including humanoid robots. And the cost is much expensive, more expensive than human labor. So if it's a like space industry, the cost of human like labor is 130,000 US dollars per hour. So yeah, it's gonna be good business. But if it's a terrestrial market, it's very difficult for us to make a good business using the general purpose robots such as humanoid types of robots. So yeah, we focus on that.
But even I think you already answered my next question, because I was going to then ask from independent of a humanoid form factor, a lot of the things you've described as use cases in space, like construction or mining, if I look at those sectors on Earth, like they're maybe a little bit roboticized, but they're not a lot. Excuse me, they're not a lot roboticized, right? If you go like average construction site, there's you have these big machines, and the big machines, they look the same for like many decades. And then somebody is driving the excavator and all of this. So I was going to ask you whether you also see a terrestrial market for your products, but I guess you would say that like it's very established, it's not very expensive, and maybe that there's actually less need. Or are you pursuing any terrestrial avenues at all?
In the future, yeah, like especially me individually, I hope to expand our capability to terrestrial market. But it's not short-term plan, but a long-term plan. Like when I established our company, I have conducted a lot of like interviews and researches to potential markets, including space market and disaster rescue, plant maintenance, remote medicals, but technically and from a business point of view, it's very difficult to like realize the high performance and low cost general purpose robots competing human labor, and it also very I believe it was also very difficult to create a good business using that general purpose robotics technologies. So it's not long term, but actually this is a kind of like side story. But when I established our company, I also considered and followed how to expand computer. So actually, general purpose robotics technology like can be categorized as an extension of human physical capability, and a computer can define the extension of human brain capability, and that became a good business from government and enterprise, and finally consumers, alongside with the progress of the performance and cost reduction. So it would take 50 years to make a good business as a consumer business. And I believe extension of human physical capability is a general purpose robotics technology will also follow our same steps. So now it's a performance of general purpose robotics technology as an extension of human physical capability is a very limited and expensive cost. So we should create a good business as a government business, such as like Apollo Age. But if we can increase the performance, enhance the performance of general purpose robotics technology, and reduce the cost more and more, we can, the general purpose robotics technology is going to be a good business for enterprise use cases, and such as plant maintenance and disaster rescue. And finally, that technology will be core products and mass product for consumers. But it also will follow same steps, 3 steps, and it will take a lot of time to be a good business and good consumer business.
Yeah, that makes sense. So if people want to get involved in this very exciting mission, are you hiring right now? And if so, what types of people are you hiring? Are you hiring in Japan, the US, both?
Yeah, we are very actively hiring there in the US, in Torrance, California. And actually, we have started in Japan, but we have relocated everything from Tokyo to the US, including headquarters and all of the manufacturing functions, and from Japan to the US. So now we are our headquarters located in the US, and all of the manufacturing facilities and functions located in the US, California. And we are now actively hiring in the United States, in California, Torrance office, both business development and legal and engineers. So yeah, we please apply for the Gitai.tech website, and yeah, it will be great if we see the interview.
Terrific. We'll put your website in the notes to this episode so people can look up your job openings. And then so the final questions of the podcast are always the same. It's basically two questions. One was the first question is, so you're generally I can tell a space enthusiast, and of course you're doing again very exciting vision with what Gitai is doing. If you were not pursuing Gitai, if like you had to pick some other area of space business activity that's very exciting, what would be one example?
Yeah, it's a very difficult question, but before the development of the humanoid robots as an individual project, I also had developed virtual reality applications. For like Oculus Rift and HTC Vive. So like the kind of virtual reality and mixed reality applications, I might establish the company as an entrepreneur to pursue the possibility to upgrade our interfaces from two-dimensional interface to three-dimensional interfaces. So yeah, that is about the interesting challenges as an entrepreneur.
Mixed reality, so virtual reality, augmented reality. Have you tried the Apple Vision Pro?
Oh, not yet, actually. but I have tried like various Quest, Meta products and HTC, and I have developed various applications like Windows applications for HTC Vive, Oculus Rift, and I think it's too heavy to set.
It looks heavy, but yeah, I'm actually thinking about stopping by the Apple Store later. I'm curious. But anyway, we don't want to talk about Apple here. Let me ask you the final question we always ask here, which is about science fiction. And so, do you like science fiction? And if yes, what are some of your favorite science fiction books? I guess a lot of robotics, of course, in science fiction. I'm a huge fan of Isaac Asimov and the robot series. But what are some of your favorites?
Yeah, actually, that is the biggest reason I have started to develop sci-fi like robots. And since I have loved science fiction, especially Japanese animes, such as Macross Frontier, Code Geass, and Gundam, that kind of sci-fi space or like robot cartoon animes. I was very big fan of that, and so yeah, that is my recommendations, and I'm still a big fan of these animes.
Great, I highly recommend Gundam for sure. I don't know the other ones, but I will look them up. But Sho, thank you so much for coming onto the podcast. Really interesting to be at Gitai. Best of luck with your in-orbit demonstration, and I hope that this vision of a large robotic workforce will come true.
Thank you for having me.
Well, that's it for another nominal episode of the Space Business Podcast. If you like this podcast, please consider giving it a 5-star rating on your favorite podcast platform, such as iTunes. You can follow us on Twitter at podcast_space. Also consider supporting us at www.patreon.com/spacebusinesspodcast. If the podcast got you interested in learning more about the business opportunities in the space economy, check out my new online course on space entrepreneurship on udemy.com. The link is in the episode description. Lastly, if you have any feedback, including ideas for guests, and that may include yourself if you have an exciting space story to tell, or interested in being a sponsor, drop us an email at spacebusinesspodcast@gmail.com. I look forward to seeing you for the next episode.